All right, welcome to our next video in programming in Java. This is one of the project videos. This is the introduction and part one to FracCalc, which we also call fraction calculator. This is typically the first large project we do in AP Computer Science. It's a ton of fun. It has 3 checkpoints and a final version. And I've got a 8-page PDF that should be provided with the assignment when it's assigned, but I wanted to kind of walk through a couple of details, show you an example of an execution of part one, give a little bit of pseudocode to help you start part one, and that'll be our video for today. So what is the fraction calculator? The idea is it is a program that when it fires up prompts the user for an input, and it's assumed that that input takes the format of a number, an operator, and another number. So you can see an example of a test execution here, which is 1 plus 2, which then it's repeated back to the user that 1 plus 2 is 3. We see this 1 underscore 1 slash 2 plus 1. That's meant to represent the mixed fraction 1 and 1/2 plus 1, which, as you can see, becomes 2 and 1/2. 2 1/3 minus 4/5 becomes 1 and 8/15. And then, as is true with most of our user input loops, as soon as we say quit, then our program thanks us and we've exited. So the idea is we need to be able to handle any kind of number, whole number, what I'm going to call a proper fraction, though there are examples of improper fractions where the numerator is greater than the denominator. I'm just going to classify this category as the proper fraction because you will see number slash forward slash and number to represent numerator, the slash, and then the denominator. And then the other kind of number we might see is called a mixed number. And that'll involve a number, an underscore, another number, a slash, and then another number. And that represents the whole, the numerator, and the denominator components of a mixed number. You have to be able to handle positive and negative numbers. We're going to talk later about how to handle that. The 4 main kinds of arithmetic are to be supported. So addition, subtraction, division, multiplication. You can use, if you want to add exponents for extra credit, you can do that. If you want to add modulus for extra credit, you can do that. One of the challenges, as this is our first bigger project in AP Computer Science, is how do we parse the input? How do we take the information that's given and break it into chunks? You'll notice in my sample outputs up here, there's always a space between the numbers and the operator. That space is key. We've talked about the scanner tool and how it can be used to take in token inputs from a user from the console using system.in, but it can also be used to parse apart a string. And so if we get an input from the user taken in using the next line method, that's a string, we can give that string as a parameter to another scanner to break that into chunks. There are some folks that are going to want to parse their input using substring. It is doable. It involves a level of complexity that I think the new programmer maybe doesn't see coming. So when we get to that checkpoint, we're going to talk about techniques for parsing apart the input, and you'll see there's a scanner option, there's a substring option. If the answer can be represented as a whole number, let's go ahead and do it as a whole number. If it can be done as a proper fraction, let's go ahead and do it as a proper fraction. If quit is provided, it should terminate, and all other inputs are echoed back to the console. So if we're given valid math, it'll do the math. If we say quit, it quits. Anything else, it'll just send it right back to the console. If students want to propose extra credit, I've seen a lot of cool and creative ideas for fraction calculator over the years. I'm always open to a project proposal to give some limited number of points extra on this project. So it is really deeply important that this project be readable. It's going to include all the normal things that you would normally do, like a header. Comments, as always, are going to be crucial. We do prefer new line comments to inline comments. If there is something you feel like is very important that it be an inline comment, you can always run it by me to make sure. Our indentation should be flawless. Remember, indentation is the tool that shows when something is contained inside something else. So we indent a method to show that it's inside a class. We indent statements to show that they're inside a method. We do not want to have bad indentation somewhere because it could cause confusion about where a statement lives, and you don't want to mix up something being inside of the loop versus outside of the loop, inside of an if statement versus outside of an if statement. So take good care of the indentation. We're going to impose a limit, as this is the first big project. It might be the first thing that students have done that's over 150, 200 lines of code when it's all said and done. We want to impose some rules to make sure that things don't get out of control. If you have a method that's longer than 50 lines of code, that needs to get broken up into at least 2, if not more, different methods. This includes the main method. It can be very tempting to just take all of the functionality of fraction calculator and put it in the main method. And I promise you, not only is that bad coding, but it's a recipe for confusion and frustration. We want to break apart if there's some kind of a behavior or function that we do that's unique and important. Let's make it its own method. And remember, by making something its own method, it enables us to call it more than once. So if we find we're using the same 5 lines of code in one part of our program as we are in another part of our program, let's refactor that, make it its own method, and call it when appropriate. So we're putting a hard limit on the number of lines of code, which is 50. I don't want any statement to be longer than 80 characters. It's usually at this point in the year that students are starting to develop some confidence with Java, which is great. That's what I want. I don't want to discourage that. But usually this means we start trying to make some really fancy code happen, where we have one statement where 3 or 4 methods get called in the same statement, or we're working with a bunch. It's a very complex expression with a lot of terms and operations. We want to break these apart into multiple lines of code. I know I just said that we're going to line limit your methods, but I would rather you take the time to break apart a complex statement into 3 more easily read equivalent statements than make something that's complex that if it breaks, and likely the larger it is, the more likely it will be to break. If it breaks, it's really hard to fix and break it apart and reformat, whereas if it's 3 smaller statements, that's just not the case. So 50 line limit on your methods, 80 character limit on your statements. If you feel that the way you've written your code if there's some part of your code that cannot obey these rules, you can always ask me for permission to break it. But I will tell you, I usually reject those appeals about 90% of the time. Usually there's something that can be done to break it down to make sure we don't break these rules. Make sure you keep clean identifiers. If you write me a program that has int a or string b, I will likely ask you to rewrite it before I grade it. I would much rather your variables be named something useful like token counter. Same with your method identifiers. It should be very easy to tell what it is your variables and methods are trying to do. Also, make sure you employ white space. Notice how this statement right here is all bunched up and it makes it a little bit hard to read, whereas if you spread it out, it just helps with readability a little bit. You might also find that as you're writing the statements of your program, that if you have 10 statements all in a row, you might see these 4 perform kind of a function. So I'm going to have these 4 statements, then I'm just going to hit enter to make 1 blank space. And then I have these next 5 statements, or next 6 statements, let's say, perform a function. I'll group them together. Grouping statements by common function can be a great tool for adding clarity to your code. So have spaces between the terms and operations of your expressions. Have spaces between chunks of code to help readability. The less it looks like one continuous brick of characters, the better you'll be. Obviously, like all of these techniques, you can push it too far. I don't want to have 20 lines of white space between your methods, but see if you can find a nice happy medium where your work is easy to read and you aren't consuming many extra lines of code needlessly, or many extra lines in your program. So those are some helpful tips about what's going to be required overall in the project and ways to help yourself write something complex without getting off track. Let's talk about checkpoint 1 before we show a sample execution. So checkpoint 1 is really all about, do we remember how to set up the user input loop? Hopefully you've been introduced to scanners, which is what you'll need to get the input from the user. And we want to be able to repeatedly get input from the user until they say quit, which means we need while. And then you might have been introduced to the concept of a flag, which is a Boolean value that holds, because it's Boolean, it's true or false, but being a flag, we think of it as being an on or off position. And so as long as our Boolean flag is on, we'll continue to get input as long as it's true. And once the user says quit, we'll flip that Boolean to false, essentially shutting our loop off, putting the flag down, and now our program will stop receiving input from the user. So to fulfill checkpoint 1, you actually really only need to do a couple things. One, you fire up your program. It should greet the user, try to be friendly. You're counting on the user to behave themselves and give commands that are valid, so maybe treat them nicely. Whatever inputs they give, you'll echo back Cleveland, echo back Cleveland, Portland, echo back Portland, except before a command is echoed back, we check to see if it's quit. If it was quit, we just go ahead and say goodbye. The requirements for this project are posted in the PDF. I won't go through them here. You can review those on your own. So we're going to go ahead and take the time now to go and pull up our program. And I'll show a sample execution of part 1 working. So welcome Mr. Mulaney's FracCalc. I put a little enter command in there so that we could see whatever's put in. And I might say go Falcons. And Go Falcons gets entered back, and we're asked again. It isn't a one-time thing. There should be a while loop functioning here. So maybe we will say fly Falcons fly, and then that goes back fly Falcons fly. And if I say quit, my program stops. By the way, hot tip, if you're watching this video, you're going to get all the good tips. Use equals ignore case to check for quit. That way, if your user gives lowercase quit or uppercase quit, or some obnoxious combination of upper and lowercase, you don't have to care. You're covered. You can just say equals ignore case for quit. And believe it or not, that's the 10 points associated with fraction calculator, meant to be 10 doable points to get us into the project. Let's talk about the basic structure for FracCalc planning. This is going to be for part 1, which is really just echo and quit as a part of a user input loop. That's really all we're talking about right here. So you'll declare your class. You'll have your main method. Inside your main method, you're going to want to greet the user. You should probably declare a Boolean and a scanner. And don't forget to close the scanner when you're done. Close when done. This is me, I didn't really set this up very well. This is me pseudo-coding. Oh, man. I always think I'm spelling that wrong. Pseudo? Let's see which one looks better. Oh, I definitely think it's EU. Pseudo-coding. Oh, another typo in a Mr. Mulvaney video. Those are going to happen. All right, so we've got our class. We've got our main method. We greet the user. We declare a Boolean and a scanner, right? And then we open a while loop. And inside this while loop, let's use the scanner. Use scanner to get input. And then we probably need an if statement, right? We're going to say if input was quit, and remember my tip of equals ignore case is a great way to make sure that you don't have to worry about case stuff. Then we should turn Boolean to false, meaning that we won't loop again. And if it wasn't, meaning it wasn't quit, it was something else, we can go ahead and echo that input to the console just with a print statement, right? Just with a print statement. All right, so we're really only doing those things. When the while loop is done, seems to me that means that quit was given. We set our Boolean to false. So now we can, say goodbye to user. And then really our program is done. That's it. Gentle reminder, don't forget, I know this part is going to be maybe 30 lines of code or less. It's probably going to be pretty small. And I know I just said, don't put your whole program in your main method, but it's totally okay for this particular part to, I guess I should call this checkpoint 1. I think that's what the document calls it, checkpoint 1. It's okay to put it all in the main method this time. Excuse me. We'll look for opportunities to decompose our larger method into something smaller later on. And that's it. As always, if you have any questions, students, you can always email me Otherwise, thanks for watching.